everyone, my name is Gibbs Cullen, and I'm a developer advocate at Chronosphere, where we are working on building out a cloud-native metrics monitoring platform. And I'm really excited to be here today speaking at this month's DevTalks by Smartly.io. Looking forward to it. Thanks. All right. Hi, everyone. Thanks for joining today at the May 2021 Smartly.io DevTalks. Today, I'm going to be speaking about M3 Prometheus and kind of how they can work together to provide a monitoring solution, metrics monitoring solution at a global scale. So for the agenda for today, we'll start out talking about Prometheus, monitoring with Prometheus, and some of the limitations it has out of the box when hitting large scale ingestion. Then we'll go into talking about monitoring with Prometheus and M3 with a focus on M3. And then finally, there'll be plenty of time at the end for any questions you may have. So first, just a little bit about myself. My name is Gibbs Cullen. I am currently a developer advocate at Chronosphere, where we are providing and building out a cloud-native metrics monitoring platform. Before joining Chronosphere, I was at AWS as a product manager on the data lab team. And then here are a few links to some of my accounts within GitHub, Twitter, and LinkedIn if you're wanting to connect after the talk. So starting out, monitoring with Prometheus. So for those of you who may not be as familiar with Prometheus, giving a quick overview here. So Prometheus is essentially a single binary metric solution out of the box. It's completely open sourced and part of the CNCF. It comes with a tag-based metric ingestion format, as well as a native query language called PromQL. It is a scrape-based or pool-based metric ingestion solution, and it also is very efficient at metric storage, so meaning that it's really good at just storing metrics within inside the instances themselves. It also has a proprietary or built-in kind of way to visualize and graph metrics. Many people that use Prometheus usually opt for Grafana to kind of fulfill these needs, but Prometheus does have its own solution for that as well. And then finally, Prometheus does allow for you to kind of aggregate your metrics through something called Prometheus recording rules. And it also allows you to create alerts on your metrics through the Prometheus Alert Manager. So as you can see, Prometheus has really risen in popularity over the past few years, kind of becoming the de facto open source metrics monitoring tool. And then you can see it kind of quickly surpassing Graphite as that leader in the space. And this is mostly due to some of these key advantages we'll talk about here with Prometheus. So the first one being that it's very easy to get started. And this is because it basically just has two single binaries, one for ingestion, storage, and querying, and then a second binary that's used just for alerting. So really easy to get started out of the box. In addition, it is the CNCF recommended monitoring tool. So this means that, and this is mostly due to the kind of widely accepted exposition format that Prometheus uses, as well as the query language PromQL, which I mentioned earlier, which has been very widely adopted. On top of that, it has a very dynamic and wide range of endpoint discovery mechanisms. So it makes it really easy to use on any platform you're running, including Kubernetes, which obviously is very popular and very widely used. And this also makes it really easy to integrate and start discovering any particular kind of metric client and endpoints to pull or scrape metrics from. And then finally, it has a wide range of kind of exporters, or kind of integrations. And these, they have these listed on the Prometheus documentation, but basically there's over 200 kind of official existing integrations, and these will be found across most major software projects, especially the open source ones. And then there's also lots of unofficial ones that you can use as well. So getting started with Prometheus. This kind of diagram here shows a very basic setup, but basically what we're seeing here is we have our three services, A, B, and C. They're all being scraped by the single Prometheus instance here. And then, as mentioned, we do have, most people do choose to use Grafana for any dashboarding or visualization. So you can have an instance of Grafana kind of pointing to your Prometheus instance for those purposes. And then the same on the alert manager side, if you wanted to kind of have any alert against your instance. Okay, so that kind of gives you a good overview of what Prometheus is and kind of some of the advantages and why it's so popular. But now we'll get into some of the kind of limitations or pain points that you might experience when wanting to really scale out to a large size, like kind of your Prometheus setup. So the first pain point we're going to discuss is going to be around reliability. So in this example here, we have one instance of Prometheus scraping service A. So let's say all of a sudden this Prometheus instance goes down. So this is not great because not only do you lose any of that kind of active or real-time monitoring of your service A here, but you also lose any kind of historical data that had already been scraped and kind of stored into your Prometheus instance. So obviously this is kind of a major point of failure with this particular setup. So the suggested way to kind of get around this is to have a second Prometheus instance tied to your service so that, in case one of them does go down, that you do have a backup copy of your data. So this is also applies to alerting, since alerting is also a single binary. You would have kind of make sure you'd still have kind of one instance of your alert manager here tied to each of your Prometheus instances. And in this example, if you are having two alert manager instances here, but they will talk to each other, so you won't get duplicate alerts. So this is kind of like the suggested workaround. And that can be, that can work for some people. However, the problems come in this scenario when you are wanting to start viewing your data on a dashboard, like in Grafana, for example. So in this example, if you were wanting to do that, you would need to then put a load balancer in front of your instance of Grafana in order to kind of balance any query requests across your two Prometheus instances. So this can generally work for kind of reliability in terms of like you're gonna, no matter what, as long as your instances are staying up, you'll get at least one copy of your data to fulfill any of your query requests. The problem with this though is that if you're doing kind of a rolling restart of either or kind of any of your Prometheus instances for any reason, whether it kind of being for kind of upgrade purposes or something along those lines, then that's where the problems arise. So looking at this example here, kind of we have two charts, each representing one of the two Prometheus instances from the previous slide. And, let's say we did rolling restarts on each one, and which you can kind of see by the gaps in data across both of the charts here. So as you can see, like when you do perform like a rolling restart, you will have a gap in data because that's, during that time, your Prometheus instance will be down. So this can present problems when you are wanting to perform any query or dashboarding on your instances, because with the load balancer, basically you're going to basically get either one copy of your data or the other as your result. So this can lead to really inconsistent results because you're not really going to get kind of that full story or that full picture of what's going on. And unfortunately, there is no, I guess, out of the box solution to resolve this and kind of merge your two sets of data. So the second main pain point that we're going to cover is around scaling. Okay, so now we're going to get into a second pain point that you might experience when kind of setting up Prometheus or using Prometheus, and that's going to be around scaling. So in this diagram here, we have our three services all being scraped by a single instance of Prometheus. And let's say all of a sudden service A just starts generating a lot more metrics, and it is going to start, overwhelming your single instance of Prometheus. So instead of like kind of letting that proceed and having your instance kind of the recommended workaround is to basically have a second or separate instance spun up to basically scrape and ingest metrics from that particular service that may be all of a sudden having a lot more load of metrics. So basically this is what that would look like. And, from here you are able to kind of, point different instances of like Alert Manager or Grafana to your various instances to kind of for querying or dashboarding alerting purposes. However, the problem with this is now like you really are only going to get you're only going to be able to see like one copy or like one data source at a time when looking at your various kind of Grafana or Alert Manager requests. So the limitation with this is that. So if you are wanting to kind of have a single source of truth and kind of be able to dashboard or query or even alert against kind of all of your data and metrics coming from all of your services, then it is recommended to kind of have a third node spun up. And this is done through a process of federation. So basically by having this third node, Prometheus node, it is going to be taking a subset of metrics from your two original instances of Prometheus and kind of having a place that has kind of a subset of metrics across all of your services that you can query from or alert off of, as you can see in this example here. So that's, all great in terms of like, all good and great in that, you're now able to have like that single point to query off of and dashboard against. However, as I mentioned, this third instance is really only still going to have that subset of metrics. So let's say if what the kind of data you were looking for is not in that subset, you will have to then kind of point or reroute your, Grafana or Alert Manager instances to the appropriate Prometheus instance that may have the data that you're looking for. So this requires kind of that management overhead where you need to remember or know where all of your data lies in terms of like which instance has which data points. So obviously this can be manageable if you have kind of a smaller setup, but as you start to scale out, this becomes a lot more challenging and hard to manage. So as you can see here, like, we're kind of having these two zones, these two buckets of metrics kind of being scraped by these various Prometheus instances here. And in order to kind of get that global view, you basically have to continue the federation process down each tier that we have here. And so kind of going back to how I was explaining kind of having to manage that overhead in terms of where all the metrics lie. Now this becomes a lot more complicated because, with each federated node, you get a subset of metrics. And so it's going to be a lot more difficult and challenging to really remember and track where all of the metrics that you may be looking for, which instance they lie in, if you're looking for something specific and not just like a general overview. So that definitely is one of the pain points with Prometheus as you scale up. And then the final kind of main pain point that we're going to discuss today is going to be around efficiency. So Prometheus by default is kind of not super efficient when storing longer term data. And this is mostly because there is no built-in downsampling capabilities. So for example, let's say you have one instance of one Prometheus instance, and you're wanting to kind of store your metrics for 6 months at a 30-second resolution. If you were able to downsample this to kind of store at a 1 hour resolution, you would really see this like kind of savings in capacity. So like much more efficient at storing kind of those metrics. So that's just with one instance though. If you were to do this across 100 instances, now you can see that discrepancy is a lot larger. So kind of without having that downsampling, it really does limit the efficiency side of things when using Prometheus. And so kind of like the way to get around this with kind of the out of the box version of Prometheus is to kind of have one kind of instance of Prometheus kind of having that data stored for 6 months at that 30-second resolution, and then kind of having a second instance for that greater resolution period. And this obviously is not going to be the most efficient because now you have two data sources tied to a single service. So for example, in Grafana, like if you are wanting to query a dashboard against these metrics, you're going to have to kind of flip between the two data sources. And so you won't have that single place of truth. All right, so just to kind of recap what we discussed around Prometheus and its limitations. From a reliability perspective, it's not really designed to handle these availability zone or region failures. And it also has kind of inconsistency with its high availability model. From a scalability perspective, we kind of mentioned or talked about kind of the management overhead required when you are kind of continuously sharding these endpoints across nodes, also known as kind of federation. And then in terms of efficiency, as we just discussed, it's not the most efficient when storing these longer term data at higher resolutions, and that's because there is no downsampling capability. So Prometheus is definitely very aware of these limitations, and they have intentionally decided not to kind of build out kind of solutions for these limitations, because they really wanted to make sure that they remain a very easy to get started solution and offering, which they're so known for to begin with. So kind of in response to these limitations, they did kind of introduce this concept called remote storage. So remote storage is essentially just made up of these capabilities to perform remote read and remote write HTTP APIs. So, and this is where solutions like M3, Thanos, and Cortex come in, because they are all remote storage compatible. So they are solutions that can be used to help kind of resolve some of these limitations that you might see when really scaling up your Prometheus setup. So moving on, we're going to now talk about monitoring with Prometheus and M3. And as I mentioned, kind of M3 is one of those remote storage compatible solutions. Okay, so now we'll get into a little bit about what is M3. So M3 is essentially an open source metrics engine. It is comprised of three main components. The first one being a custom built time series database called M3DB. Then there's an ingest and downsampling tier called the M3 Coordinator. And then finally, the optimized query engine, which we call M3 Query. It was built in open source from day one back at Uber, having its first check-in in GitHub around April 2016. And it was originally built by Uber to help kind of solve their metrics and metrics monitoring use cases. And since then, it's really been proven at scale and used obviously at Uber, but also by other large companies such as Walmart, LinkedIn, Databricks, and many others that kind of also were looking for solutions for kind of their metrics monitoring use cases. And today it continues to be maintained mostly by Uber and by Chronosphere. And as I mentioned, it is designed to be Prometheus remote storage compatible. So the key features of M3 that we'll cover here, kind of tying back to those three main limitations with Prometheus at scale. So first one being that M3 is like highly reliable. And this is because it has consistent copies of all the data points that get ingested, having by default a replication factor of 3. So you'll have basically 3 copies of each data point that comes in. It's also built to tolerate node availability zone and region failures. And that's kind of in line with kind of having multiple copies in that high availability model. In terms of scalability, it was designed to have each tier kind of be horizontally scalable. And on top of that, it has been proven to store billions of metrics time series data, kind of having started back at Uber and kind of been their internal solution for metrics monitoring. On top of that, it's built with a simple operation in mind, kind of helping to kind of reduce that management overhead that you might encounter when scaling up your Prometheus instances. And then finally, in terms of efficiency, it is really efficient at storing data, especially kind of the more longer term data. And this is because it does have built-in downsampling. It also has an optimized compression algorithm that's built specifically for metrics and time series data. So now kind of we're going to get a little bit into the architecture and kind of setup of M3 here. So this is a very basic high level kind of overview or diagram of what M3 would look like kind of from an architecture perspective. So you can see on the right side of thing, we have an instance of Prometheus kind of sending in metrics via the kind of back when we were talking about remote storage, how that kind of has the remote read and write APIs. So that we're going to kind of use the remote read and write APIs to send and read, to kind of read and write metrics from to and from M3. From there, all your metrics will be then kind of sent along after being kind of replicated and or downsampled, depending on your setup, will be then sent over to our time series database tier, which is called the M3DB tier. And then from there, you can have any query requests that may come from, your an instance of Grafana, for example, go through kind of the M3 query tier to the M3DB tier to kind of fetch those requests. Okay, so now we'll get into a little bit more about the specific components and the tiers of M3. So first one we'll cover is M3 Coordinator. So as I mentioned previously, you're going to have, you're going to be able to send your Prometheus metrics to M3 via the coordinator tier using the Prometheus remote write API. And then from there, the coordinator can perform any downsampling that you may want based on your setup, or it can just also just send along the replicated raw metrics as well. But once metrics are kind of sent over to the coordinator tier, it'll perform any of that replication and downsampling that you may want, and then it'll use this concept we call quorum write to kind of write over the 3 copies of each metric to the various DB nodes in your cluster. And when we say quorum write, we basically just mean that in order for metrics to successfully write over to the DB tier and the DB nodes, at least 2 of the 3 copies have to successfully write over. So, and if that does not happen, it'll continue to retry until that does become successful. So the next tier that we'll kind of dive into here is the M3DB tier. So a couple concepts we'll cover today. First one being the namespace. So namespace is kind of most similar to a table and some other databases. But for our purposes, it kind of helps define the resolution and retention periods that you want to store your metrics at. And in general, we recommend that you store data with the same resolution and retention periods within a single namespace. So not having multiple namespaces for those same kind of retention and resolution periods. And then from there, that namespace will then kind of span across all of your M3DB nodes in a cluster. So within a namespace, all of your data will then be sharded and replicated so that there are going to be 3 replicas of each data point. And in terms of the sharding, it will be done, kind of the metrics will be randomly sharded, and then it'll be kind of done and based off of their metric ID, which is essentially just a combination of a metric name and a metric tag key value. So within a shard, 2 components kind of the time series data that we that you'll end up kind of storing within your nodes. First is that it has, M3DB has an in-memory metric index. And this is an inverted metric index that uses a trie-like structure to fulfill certain queries, as well as regex and glob patterns. And then from there, it'll then match them to their particular metric IDs. And then from there, kind of all metrics or kind of the time series data, metric time series data is then stored against the metrics IDs themselves. And then they're also kind of stored on based on time and blocks that kind of go back over time. So for example, in this diagram, we have data being stored in 2-hour blocks, which are kind of compressed by the compression formula or algorithm that we mentioned previously. And these blocks will then kind of go back over time until it kind of hits the end of that retention period defined by the namespace. So theoretically, this would keep going out until we hit that 48-hour or 2-day retention period. So this is just a very high-level overview of the DB tier. And if you have more questions or want more information, definitely recommend referring to our documentation or looking up or listening to some previous talks we've had around this area. Okay, and then the kind of the final tier we'll be talking about is the M3 query tier. Similar to the coordinator tier, we're going to be using Prometheus remote read to kind of send any metrics from kind of the query tier to your maybe Grafana instance, or kind of any sort of visualization or dashboarding instance that you may have set up to fulfill those requests. One thing that we like to mention is that in addition to being completely 100% PromQL compatible, M3 does also accommodate graphite or stat-C metrics. But basically in this setup, we're going to be using Grafana here, which will then send any kind of query requests along using that Prometheus remote read. From there, the M3 query will kind of ingest those query requests, and then it'll go to the various DB nodes in your cluster to kind of fetch the data to perform and fulfill those query requests. And when doing this, similar to the coordinator, we are using some quorum logic. This obviously is going to be the quorum read logic, which basically just means that in order for a query request to be successfully fulfilled, you have to 2 of the 3 copies of data across your nodes must be successfully fetched from the M3 query tier in order to be successful. So now we'll kind of look at what it looks like when you want to scale up your M3 setup. So obviously you have a few services here being scraped by your Prometheus instance, and then from there via Prometheus remote write, your metrics are being sent to and ingested by M3 via the coordinator. So obviously, let's say you start having a much larger ingest of metrics coming in, and you wanted to kind of scale up your M3 components. So how you do that is basically, and from a high level, focusing first on the M3 query and coordinator tiers, because those are both stateless tiers. It's going to be pretty simple to scale both of these components up. Basically, all you would need to do is just continuing to add more and more instances. However, in terms of the DB tier, that is actually a stateful tier. So that's where it can get a little bit tricky, because now that if you wanted to scale this up, you would have to kind of update any configuration files kind of appropriately or accordingly to kind of make sure they're aware of the increase of instances or nodes that you are kind of scaling up or down in that tier. So another thing about M3 is you are able to kind of have it span across multiple regions or zones as well. We'll be talking about zones in this slide, but this slide will kind of show you how that kind of setup looks like across multiple zones and how we can handle and manage these zones reliably. So you can see here we have 3 zones. On both the read and write sides, we have load balancers set up in front of your M3 setup here. Basically on the right side, it's being used to help distribute any kind of write requests coming in across the 3 zones via the coordinator, and then same on the query side or the read side. The load balancer is being used to kind of help distribute your query requests coming in evenly across your various zones. The one thing to note here is that you can see that on the coordinator query side, these tiers are talking to kind of the nodes, or kind of talking to components across across the zones. So from the coordinator, in zone 2, for example, it'll be writing metrics to kind of all these, each one of your DB nodes. So each replica will be sent to a separate DB cluster in a separate zone. And same with the query side. So if you are wanting to kind of query across your zones, you can do that through the M3 query tier, which is able to then kind of talk to the M3DB clusters across all of your zones before kind of consolidating and then kind of sending back to Grafana to fulfill those requests. So the main thing to kind of note here, though, is that On the DB side, it's very important and recommended that you keep a full and single replica of your data from a single cluster within that kind of zone itself. So as you can see here, we don't have any of our DB nodes talking to each other. They only are really talking to each other via the query and coordinator tiers. And this is to kind of help with the reliability standpoint. So if you did have a zone go down, you'd still have at least 2 full copies of your data because you have, 2 full sets of data living or like a full set of data living within a single node or zone, sorry. Because M3DB is a stateful tier, and like when working across zones, this can kind of be difficult to manage when you're wanting to scale up or down. We do offer a solution for this via our M3 operator tier, it's a Kubernetes operator that we have in open source, which basically just allows you to help automate your M3 setups in terms of wanting to scale up or down your DB tier. So basically all you need to do is just tell the Kubernetes operator the number of instances you want in a cluster, and then from there, it'll kind of take care of scaling things up and down for you. And then finally, we're going to talk about multi-region of reliability. So just like M3 has kind of the ability to support multi-zone, it also has the ability to support multi-region. And so kind of the main point here, similar to what we were kind of covering on the previous slide, is that to really make sure that we're maintaining that reliability perspective, we want to make sure that a full set of data, a full set of kind of your metrics data is living within a single region itself. So kind of all of the data that is kind of being created and ingested in a single region should really just stay in that region. And if you wanted to talk across regions, query across them, dashboard across them, alert across them, really, we only really recommend that you do this by having your query tiers talk to each other. And that's really the only kind of link that these kind of regions should have. And this is mostly also due to kind of that reliability standpoint, so that, if you did have our region go down, you still have one full set of data and metrics kind of stored and available to fulfill your requests. Basically, that we're going to be covering today. Obviously, there's a lot more information out there about M3. This is all pretty high level. And so if you wanted to dive in more into the weeds about kind of what's going on with M3, we have our website as well as our documentation, which is actively being revamped and kind of updated. We also have a very active Slack channel with a kind of pretty large community, a pretty large and engaged community. So anyone's obviously welcome to join that Slack channel in the community. Invite link is here. Same with our GitHub repo for M3. Also pretty large community there as well, where we have kind of various contribution guides and are very open to receiving any sort of contributions in terms of feature requests or anything that may come up from that side of things. So so definitely encourage anyone to check those out if they're interested. And then finally, we do have a monthly office hours slot set up. So every third Thursday, and you're going to be able to sign up with this link here. So I'm assuming these slides in this deck will be sent out after. So if not, more than happy to share it, whoever's interested. But yeah, thanks for listening. And I guess we'll open it up for questions now.